Our topic for today will be acidity and alkalinity, that is pH. And our learning objective today will be calculation on pH. So we are going to focus on calculation on pH. Now, if you remember in the last class, I talked about pH and I also talked about the meaning of pH. But in this class, we are going to be looking at calculation on pH. All right, so calculate pH. Now, there are some formulas you must get used to or get conversant with. The first formula is your pH. The formula for your pH is equal to negative log of hydrogen ion. All right, we also have POH. All right, so POH is equals to negative log of hydroxide ion. That is the second equation. The first one is hydrogen ion. That is when you're calculating the hydrogen ion, you're calculating the pH. For the hydroxide ion, you are calculating the POH. Now, also there's a formula connecting the pH and the POH. Now, the formula is this equation 3, which is your pH plus your POH is equals to 14. All right, let's see how these formulas are being applied. Now, if you look at the first example you have on the board, now the first example says, calculate the pH of 0.005 mole per dm cube of tetraoxosulfate 6 acid. Tetraoxosulfate 6 acid. Now, since this is an acid, we have to calculate the pH. All right. Now, when you are given the acid, the first thing you have to do is this. Don't just take the hydrogen ion and start calculating. First of all, you write what you call an ionization equation for that acid. Now, for H2SO4, that is hydrogen tetraoxosulfate 6, when it ionizes, you are going to have 2 mole of hydrogen ion plus the sulfate ion. That is the first thing. All right. So now the hydrogen ion in this case you were given from your question is 0.005 mole per dm cube. Now, since you are given 2 moles, all right, since you are given 2 moles, you times it by 2. So you times this by 2, this becomes 2 times 0.005. That will give you 0.01 mole per dm cube. All right, so that becomes your hydrogen ion. So you see your pH is equals to negative log of hydrogen ion. So your pH becomes equals to negative log of 0.01. All right, so your pH becomes equals to negative log 1 times 10 to the power of minus 2. All right, now normally there's a shortcut for this. When you're calculating the pH of a substance and you are given the number in standard form, normally most of the time when we calculate the pH, even after using your calculator, your pH are usually equals to the power that you were given. All right, so that means our pH, when you calculate, you put your calculator negative log of 1 times 10 to the power of minus 2, you are going to get 2 as your final answer, which is equals to this 2 that is here. All right, so that is how you calculate the pH. Now for number 2, this is number 1. Now for example 2, they said find the pH in which the hydrogen ion concentration is this 6.38 times 10 to the power of minus 6 mole per dm cube. Now if you look at this, you are not given a specified acid. All right, so there's no need of writing the ionization equation. All right, so you just go ahead and use this value as your hydrogen ion concentration, which is equal to 6.38 times 10 to the power of minus 6. So that is your hydrogen ion. So you see your pH is equal to negative log of hydrogen ion. So that will give you your pH as negative log, all in brackets, 6.38 times 10 to the power of minus 6, which is equal to now negative log. Now, if you use this, according to law of logarithm, you have log 6.38 minus, all right, minus 6 log in base 10. All right, let me put the other bracket. So this becomes equals to now negative log 6.38, all right, plus 6 log in base 10. All right, now if you look for the logarithm of 6.38, if you type on your calculator minus log 6.38, you are going to get 0.8048 plus, now if you punch 6 log in base 10, you are going to get 6. All right, remember there's a minus here, you bring down your minus. All right, so from here this becomes equal to, if you do this, your pH from this junction, when you do minus 0.8048 plus 6, that will give you 5.195, which is approximately 5.2 as your pH. All right, if you look at this, we have the third example. All right, so I want you to go and learn this. Now in the next class we'll look at the number 3 of our example. Please, I hope you enjoy the class, so please do have a nice day. Bye bye.